Good morning. In this lecture series, we see about how A is interpretation is working. The interpretation is classified into two. One is a physical interpretation and a mathematical interpretations. The physical interpretation is the continuous physical model of dividing into the finite pieces is called as the elements and the law of the nature and applied on the generic element. The results are then recombined to present the continuum. The mathematical interpretations is a differential equations representing the system converted into the variational form, which is approximate by the linear combination of the finite set of the trial function. So there are different types of notations are there. So the one is called as elements are defined by the following properties. The one is like a dimensionally and nodal points, geometry, degree of freedom, nodal forces. And the next one is we have different classification of the according to types of problem. So if you are classifying into one-dimensional, two-dimensional, three-dimensional, and going on. So the one-dimensional is like a linear and non-linear, and the two-dimensional similar and three-dimensional. So these are the called as the following history of the FEA. This is called as 1940 the structural engineering and one-dimensional element. Going for the 1950, the direct stiffness methods, the two-dimensional elements, the 1960, the finite element introductions and the three-dimensional elements, and 1970, the three-dimensional element, the large deflections and the thermal analysis. In 1976, the large deformation of the nonlinear dynamics. In the present, the new elements and the softwares. So these are the historical view of the introduction about the how they are evaluation of the FEA. Then the finite elements steps, we have to classify the following steps. The first step is the identify the problem, that what the physical conditions are given to and what is the required to be found. And creating a model, the analyze is applied to an appropriate model, the representing the original physical model, analyzing a model in a such much easier than dealing with the original problems. So discretization of the models is model is the divider into the finite continuous mesh to be analyzed using the FEA. So defining relations, the appropriate relations stiffness matrix are formed to the find out the primary unknown is like called as a displacements. So when going for the heat treatment, we find out the unknown display temperatures. The solving for the unknowns, the primary unknowns are then used to find the secondary unknowns, which are the stresses, etc. The interpreting the result that can be interpreted on the original physical problems. So these are the steps for the FEA, the interpolations, element and node and degree of freedom. For example, so if I am considering the types of structure, okay, I want to apply the load at the top of the edge. Okay, so here I have to classify into two types of area is called as a AI and AB. So here I have to load apply on the downward direction. So what I have to consider? So you have to consider as a model. Okay, the structure you have to convert as a model, and the model is a very important. You have to consider as a rigid body. So what are the conditions you have to given for this case? For example, the one end I have to apply the load. Okay, that is a smaller area, and the larger area is a contact with the rigid support that is called as a ground surface. Okay, then move for the discretization model. This is primary important. So this is what I have to do is I have to segregate the element according to our problem decisions. Okay, so here I have to segregate the three types of element I have to segregate here. That is like 1, 2, 3. Then 1, 2, 3, I have to consider the physical representations. In this stage, you have to consider how many nodes and how many elements are there. Okay, based upon the nodes and based upon elements, you have to assemble them and equating the general equation of the following cases. Okay, so this is the foremost thing to utilize in the FEA for the discretization modeling. Next, we have to understanding purpose only the finite element representations. So what here is So here you have to apply the line diagram representations. So here the line diagram representation shows the single line and where is the area of the particular element I have to represent. So for example, A1, A2, A3, and what is the load is applied. So these are the representations you are to using for the while solving the problem is based upon the FEA cases. Okay, so here the what are the advantages of FEA is, so here the FEA is applicable to find the any field of problem. So if you have any structural or non-structural problem, you can analyze this. Okay, so is there is no restriction for the shape or size of the model, and the boundary conditions and load conditions can be taken anywhere in the model according to required unknowns. Can you deal with the composite materials, and the mesh size can be easily be the changed according to the desired accuracy. And it is used in for the different types of analysis structures like a non-structure problem, the stress analysis, buckling, variation analysis, fluid flow, heat transfer, distribution of electric and magnetic potential, etc. So these are the some softwares we already discussing. Okay, so the both the softwares, all the softwares we have to deal with the pre-processing, numerical analysis, and post-processing. So these are the main process of the FE analysis. The next lecture series, we see about one numerical problem based upon the Rayleigh-Ritz method and Galerkin method. Thank you.